let us study about a Wheatstone'S Bridge now. Okay. So a Wheatstone'S Bridge is an important application of Kirchhoff's rules. Okay. So let us see the circuit first. Okay. And first we'll see what is useful for. It's used in many transducers. That means many devices we use it. Wheatstone bridge. Okay. Let us see the circuit here. In this circuit there are 4 resistors. Okay. I'll draw it here on this side. These are 4 resistors here. Then we have a cell like this. Okay. The cell has a EMF Xi. This is a positive, this is a negative. And in between we have a galvanometer. Okay, draw it a little bigger in size. This is a galvanometer. The 4 resistors we name it as P, Q, R and S. Okay, these are 4 resistors. Now let us see this thing. You see the battery here, a cell. It gives a voltage and it also gives a current there. Okay. The current I goes this way. Okay. Always current starts from positive. We take conventional current. Then as it goes here, we will name this point as A. This point is A. This point is B. This point is C. And this one is D. Okay. So as the current goes to A, it will divide here. Okay. It divides as 2 currents here. This current will be I1. And here this current here, that will be I2. Okay, I1 top, I2 is down. Now see, I1 goes here. Okay, let's see at B what happens at junction B. It will again divide into 2 parts. One current goes this way, that will be I3, and another current goes this side. Okay, that current we can mark as IG, the current through the galvanometer. Okay, so at B it divides into 2 parts. Then let's come to D now. Okay, at D what happens is I2 and IG will meet here. And we'll get a current here in this direction. Okay, like this. This current will be marked as I4. Okay, so we have different currents here and different things here. Now what we do now, we have to use the Kirchhoff's first rule and Kirchhoff's second rule. Okay, so first I'll say the Kirchhoff's first rule is for Kirchhoff's current rule. Okay, so what we do now, we apply Kirchhoff's current rule. I'll write short form here. Kirchhoff's current rule, that means the first rule, to the junction B. Okay, let's see here at this junction what happens. Okay, so first you must remember what is the Kirchhoff's current rule or what is the Kirchhoff's first rule. Okay, it states that the algebraic sum of all the currents meeting at a point is 0. Okay, so this is the point here, this is a junction here. The current going here is I1. Okay, if a current goes to the junction, it is positive in length. Okay, and see I3 and IG are going away from junction. They're coming down. IG comes down, I3 goes this side. So IG comes out of junction. Okay, so let us minus IG. Okay, why minus is going away from the junction. I3 also goes away from junction. So minus I3, that's equal to 0. Okay, it's clear. Now right here this side, we apply again the Kirchhoff's current rule. That means the first rule. Current rule means first rule to the junction here, that is D. Okay, this point, this junction D. Okay, now see what are the currents coming towards junction and what current goes away. Current I2 comes towards junction, so current I2 comes here, so plus. Okay, and current IG also comes towards junction, so that will be plus IG. Okay, what current goes away? Current I4 goes away, so write as minus I4. That will be equal to 0. Okay, this is the first thing. Very simple only. Okay, then now what we do now, we must apply the Kirchhoff's second rule. Kirchhoff's second rule is also called as the Kirchhoff's voltage rule. Okay, so apply Kirchhoff's voltage rule to, now we must take a loop here. Okay, I'll take this loop here, A, B, D, A. A, B, D, A. Okay, now we'll go this side, so it's more easy to see this thing. Okay, so apply Kirchhoff's voltage rule to A, B, D, A. Okay, A, B, DA. Let's see this now. In the circuit, okay, what does the Kirchhoff's voltage rule state? The algebraic sum of the products of current and resistance, okay, in a circuit is equal to the total EMF. Okay, now I'll take this loop here, A, B, D, A. Okay, You multiply, first we'll take this one. Current into the resistance, I1 into P. So we have here I1 into P. Okay. And then this one. Okay. IG. I'm going clockwise direction. See here, I'm going this clockwise direction in this loop here. Okay. So I'll just draw it here itself for us to understand. I'll draw it outside. Okay. Then we can erase it out. It's more clear this way. Okay. So this will be the current I1. This is P. This will be the current IG. And this G means galvanometer resistance. Okay. This is the resistance R. And this current will be I2. I take the loop here A, B, D, A, B, D, A. Okay. In this loop, let us see what happens here. Multiply current into the resistance. So I1 into P. Okay. And then see here, I'm going with this clockwise direction like this way. Then IG into G. That means plus only will come. Plus IG into G. We'll take chalk here. Then see here, as you go down, and we're going this way now. Okay, this current I2 comes opposite to us. So you write as minus sign. Okay, minus I2 into the resistance R. Okay, that's equal to 0. Why 0 is there is no cell inside the circuit. Okay, in this part there is no circuit. ABD there is no circuit still. Okay, so that's one thing. Now what we do, you apply Kirchhoff's voltage rule. Okay, that is second rule to the entire loop here. That's A, B, C, D, A. Okay, I'll rub this and draw that also. How it look? Okay, A, B, C, D, A. So it's like this way. You see this? Okay. Resistors here, another resistor here, resistor here on top, and the resistor this side. Okay. This point is A, B, C, D, A. Okay, we not take the galvanometer now. Okay, just see, I'm taking this one part only. Okay, so the current here will be I1, this is P, and the current this side will be I3, Q, and this side current goes this direction, that will be I4, and this is S, and this side current will be I2, and the resistance will be R. Okay, let's apply this rule and see. Excuse me. So I'll draw a line here. Okay, now, so when you apply that, you must multiply current into the resistance. So I1 into P. Okay, we're going clockwise direction only. Okay, then this one I3 into Q. So it will be plus I3 into Q. Okay, it's clear. Now see here, as you go like this way clockwise direction, this I4 comes opposite to us now. Okay, we're going this way. I4 comes opposite. So minus I4 can write here. Minus I4 into this. Okay, multiply current into the resistance. Then as you go this direction, you can also see current I2 also comes opposite to us. Okay, this direction. So we write minus sign. Minus I2 into R. Okay, that's equal to 0. Okay, because there is no cell in this part here. In the top part there is no cell. Okay, so EMF is 0. Okay, let me rub this out. Now you see what happens here. Okay, we adjust that PQRS so that the current going through galvanometer is 0. Okay, so when you adjust it, so if current IG, that's current through the galvanometer, is equal to 0, what will happen? Okay, let me take the equations here. This one is equation 1. Okay, this is equation 2, 3, and this one is 4. Okay, take a chalk. Then next you see, you apply these rules here. Okay, let me write. Okay, I'll write here straight itself down. Okay, we have space here now. Right here. So if IG is 0, what will happen to the first equation? Okay, I1 minus IG becomes 0 now. 0 minus I3 is equal to 0. Okay, so I can take this minus I3 to the right side. So you can see here I1 is equal to I3. Okay, this is the first point we need. Okay, so this equation we can write as equation number 4. Okay, sorry 5, this is 5, already written 4, it's 5. Then let me take the second equation, this equation here, second equation, I2 plus Ig minus I4 is equal to 0. In this case, Ig becomes 0. So write here 0 here. Okay. So what happens is minus I4 goes to the right side. Okay. So it becomes plus now. So I2 is equal to plus I4. The plus you can leave it. Okay. So this one is that we got now. This is equation number 6. Okay. Equation number 6. Then let's now see next one. Okay. This one. Okay, I'll take this equation. That's I1 into P plus Ig, that has become 0 now. So 0 into anything is 0 minus I2R is equal to 0. Okay. I don't know whether you can see that also. I'll write here. Okay. I'll write this side so it's easy to see that. The seventh equation right here. Okay, I'll just continue from that. So I1 into P, I'm taking this equation 3, okay, and then see, plus Ig becomes 0, so 0 minus I2R is equal to 0, okay. Then I take this minus I2R to the right side, so it will become plus. So I1 into P is equal to I2 into R, okay. This one will take as equation number, say 7, okay. Now what I'll do now, I'll rub all the things and I'll write only the equations now, okay. This one, equation number, we need to know, okay, I'll write only the equations and see. Okay, let me rub this out. Equation 1 we don't need, okay. So this one, equation 2, it's not needed, or continuation, okay. This equation 3, equation 3, okay, it's not needed now. Okay, we'll use this equation 5, 6 and 7, okay, up to this one, I can wrap up to here. Equation 4 also we will need, okay. It's a little later. Okay. Equation 4 I'll write this side, okay. Equation 4 we have got here. That is, I'll write each equation here. For equation 4, I'll write first. Okay. Equation 4 will be I1 into P plus I3 into Q, and then minus I4 into S minus I2 into R. Okay, that's equal to 0. This is equation number 4. Then equation 5 we got here. I1 is equal to I3. That is equation number 5. Equation number 6 we got, that is I2 is equal to I4, that's equation number 6. And then equation 7, okay, that is I1P is equal to I2R, okay, this is equation number 7. It's very simple only, okay. See, I'll take a chalk here. Now what we do now, we are going to substitute this equation 5, 6 and 7 in equation 4. Okay, so substitute 5 and 6, we'll just use 4, sorry, 5 and 6 only, okay, in equation 4. Okay, so let's substitute this and see what we get now. Okay, 5 and 6. So I1P we write as it is, I1 into P plus this I3Q now. Okay, instead of I3 you can write as I1. So I1 into Q. Okay, then see here minus I4 is there now. I4, instead of I4 we can write as I2. Okay, see this equation. Instead of I4 we can write as I2. So we have here minus I2 into S. Okay, and then minus I2 into R. We'll leave it as it is. Minus I2 into R is equal to 0. Okay, we got this now. So what I do now, I'll take all the minus terms to right side, it will become plus. So we get here I1 into P plus I1 into Q is equal to I2 into S plus I2 into R. Okay. Now what we do, we take all the I1 terms together. So I1 into P plus Q is equal to, this side we have I2 common, so I2 into R plus S, you can also write S plus R also. Okay, S plus R you can write as R plus S also. Okay, both the same only. So this equation I named as a equation number 8. Okay, so next what we do, we have to divide equation 8 by equation 7. Okay, so divide equation 8 by equation 7. Okay, divide and see. So I1 into P plus Q, okay, I'll write the equation 8 first. I2 into R plus S, okay, divided by this one, equation 7. That will be I1P, and this side will have here this one I2 into R. Okay, so what is common here? I1 cancels, I2 will cancel. So you get here P plus Q by P is equal to R plus S by R. Okay, it's now simple only. Okay, what we do, I'll rub this out. There is no space here. I'll continue on top. Okay, so what I'll do, I write this equation on top. P plus Q by P is equal to R plus S by R. Okay, it's very simple. Just see this. So what do we do now? We take common denominator. Okay, we take denominator separately. That is P by P, you can write. Okay, plus Q by P. Okay, then this side will have here R by R plus S by R. Okay, so we can cancel the common terms here. So P and P cancels, and we'll get here 1. Okay, R and R cancel, we get the term 1. So 1 plus Q by P is equal to 1 plus S by R. Okay, left side we have 1, right side we have 1. We can cancel that also. Okay, if you cannot say that, you can take this 1 this side, you can minus. Okay, so what we get is Q by P is equal to S by R. Okay, take the reciprocal. When you take the reciprocal, we get here P by Q is equal to R by S. Okay, this is the final equation we need. Okay, so during the balance condition, that means when the current through the galvanometer becomes 0, when Ig is 0, okay, this equation is satisfied. Okay, so P by Q will be equal to R by S. Okay, it's a very simple equation only, derivation only. Just go through the steps. Okay, read through the Kirchhoff's laws. Okay, it's very simple only. Thank you for watching.